Hey guys, so today we'll be dealing with the concept of IP subnetting and the DHCP servers. So first we'll start with what is subnetting and why do we need subnetting. So subnetting is nothing but dividing your IP address into bigger network into smaller networks. So as you can see over here, for example, we have a network of for say 192.168.1.0 is the IP address given us to the organization. Now, for example, if we want to break this IP address into smaller branches, if for example I have my organization's branches in four different cities, so I don't have to buy a lot of IP address for that. I can divide my one IP address into subnets and configure them as a whole network. So let's say I have 100 users over here, 30 users over here, 15 users over here, and 40 users over here. So according to my needs, I can break my network and can utilize the IP address very efficiently. So if, for example, I have 2,000 people working on a single IP address, I can expand that to let's say 4,000 or 5,000 people. The whole purpose of making uh, the subnetting concept was to increase the network in case we want a lot of networks by snatching the bits from the host side, or increasing the host bits from by snatching from the network side. So how we do that is, let's say I want 192.168.1.4/24. 24 are the network bits and I want four subnets. So in this example, if we try to imagine, so over here every interface between the router has one network. So let's say 1, 2, 3, 4, 5, 6, 7, 8. So I have 8 networks over here. I need 8 networks. So in those conditions, my formula becomes 2 raised to n. Number of subnets is equals to 2 raised to n. So let's say in this example, my number of subnets is 8. So my n becomes 3 bits. So what I'll do is I'll snatch the 3 host bits from my network. Over here, I'm just snatching 2 bits for simplicity. So 4 is equals to 2 raised to n, where n is equals to 2 host bits. So what I'll do is I have my initial IP address 192.168.100.000 and 4 zeros. So as you can see over here, 00011011. These are the uh, different IP address I can assign. So what I get is 192.168.1.0/26. 1.64/26. So over here 26 signifies the importance that we have increased our network from 24 to 26. Subnetting is very useful when organizations want to have a lot of networks and want to utilize that IP address very effectively. Okay, so this was about the subnetting part. Now we move on to the our network architecture. In this network architecture, we have made two different networks. This is let's say network A, and this is let's say network B. I'll just try to zoom in a little bit. Yeah. So let's say this is network A and this is network B. So now my end purpose is to send a packet from this end to this end. And over here, unlike the experiments we have done before, the IP address is not static. The IP address is generated by the DHCP server, which dynamically allocates the IP address based on the address pool. So over here we have three routers. This is the network 1, which is 192.168.1.0/26. Then we have network 2, the interface between router 6 and router 7, for which the interface is 192.168.1.64. And there are two interfaces. The one connected is the gigabit Ethernet 0/0, which is connected with the switch for which the IP address is 192.168.1.1. That is the default gateway. And for serial 0/3/0, which is connected to the router, the IP address is 192.168.1.65. Okay, so over here we have two interfaces, since router has two IP address for every interface it has, and it is connected to the main central router, which is connected to two side routers. So over here as well we have two interfaces, and two IP address has been allocated. So over here, as you can see, serial 0/3/0 is assigned 192.168.1.66, and 0/3/1 is 192.168.1.194, which is connected to this router. Okay, so now towards the right we come to the third network. Yeah, so over here we have 192.168.1 I'm sorry, 192.168.1.129. So this is our final network, network B. So my purpose is to send packets from year to year, but before that we need to configure a few things. So over here, I'll be assigning or making changes in the multi-layer switch port. So in the multi-layer switch port, I go to the config, I go to the interface, interface gigahit. So basically what I'm trying to do over here is I'm not able to find the configuration, but what I've done is, as you can see in the box over here, we have towards the end, as you can see, we have assigned the IP address as 192.168.1.2. So we'll be assigning the IP address, and we make all the active connections with the end devices. In the router we assign the IP address, like I've said before, but along with IP address we also do the IP routing. So over here, as okay, so the IP routing command has is not been activated, is not over here, but basically IP routing means that whenever you send a packet from this device to this device, so over here, whenever the packet comes over here, so if for example I'm sending the packet from network A to B, so over here I am routing the packet intended for network B, and it is supposed to hop to this address to help the packet move forward. So IP routing, what it does is it sends the packet. It when the packet reaches the router, it identifies the destination address. So for example, I am sending it over on this network, 192.168.129. So I'm sending it on this network. It identifies it, and now it takes a appropriate hop, which will be 192.168.66. So this will be the hop which I'll be doing, and through which my packets will directly hop onto this interface. And now this interface will have again two IP routes, one for hopping the packets from this interface to this interface, since our destination address is in the network B. So I'll just show the show IP. I don't remember the command actually. Yeah. So uh, now when IP routing is clear, we try to understand the DHCP server. So over here, DHCP, for DHCP server, we go to the config, we assign the default gateway, and then we go to the services, and then we go to the DHCP. So over here, as you can see that we have started the IP address as 192.168.1.4. So that means that the dynamically assignment of the IP address to the end devices will start from 4 and not from 1, 2, and 3, because as I have mentioned earlier, one is the default gateway which is given to the router, two is assigned to the switch, and three I think three is the IP address of the server. Okay, so IP address of the server is three. So now the end devices is supposed to have the assignment from four till whichever number we want. So for our purposes, we have right now have maximum users as 50. So up to 50 members can actually 50 end devices can actually connect to this network. And then yeah, that's it, I guess. So from DHCP point of view, this was the most important thing to take care. Now we'll try to simulate and send the packet from one end to the other. So we have already set up the simulation. So we'll be sending packet from this PC to PC2. So let's see how it goes. So as you can see that it is moving, packet is going from PC1 to the multi-layer switch. Then it's going to router 0, and from router 0 it goes to router 1 or router 7. Now from router 7 it again moves forward to the from router 7 it again moves forward to the router 2. Yeah. So from router 2 it identifies where it's supposed to go, so it heads back to the multi-layer switch. Now multi-layer switch takes the destination address and sends the packet to the intended. Yeah, so over here as we can see, so only this PC responds to the email, responds to the packet, since it was the only one. Yeah, wait. And now it sends back the response. So as we saw that whenever the packet comes, it is distributed to all the PCs, but the only PC which the user has intended or the source has intended accepts the uh, packet and sends an acknowledgement. Acknowledgement sent is also sent through the similar process. Over here we can also check the inbound and outbound PDUs. So over here you can actually see inbound PDUs where we have the destination address, the IP address, and the source address. So basically we have the entire network configuration and we can see where the packet is heading. So in this way, we have successfully implemented a DHCP configuration in which a DHCP server assigns the IP address to the end devices dynamically. We also understood the concept of subnetting and how subnetting is useful is very useful for the organizations. And we also saw how the packets try to hop from one network to the other by using the concept of IP routing. Thank you.